All right. Hello, everybody. Thank you so much for joining us today. Good morning, or good evening, wherever you are. Well done joining this awesome workshop. Today, and we have Valentina Alexander here, our developer advocate, and we will talk about building AI applications on the blockchain and integrating AI with the blockchain. Buckle up. It's going to be an awesome session. And over to you, Valentina.
Thank you so much. Alrighty, so let's get right into the block magic. I hope that you all are enjoying your hackathon experience thus far. And I'm very proud to be here to help introduce you to the magic that is Chainlink Functions and how we can use those functions in order to connect blockchains and AI. So, to quote our CPO, Kamal El Mujahid, imagine what happens when dApps are connected to AI via Chainlink oracles. And that's exactly what we're here to do today, to imagine that potentiality. And a lot of people, they look at artificial intelligence, they look at blockchains, and they see them as two very distinct entities that serve two very distinct purposes, which is true. And prior to what we're going to be getting into later today, there really wasn't a way to integrate artificial intelligence and blockchains in a very seamless manner. And there's a lot of contrast that exists between artificial intelligence and blockchains. Like artificial intelligence, it's very secretive and siloed and highly centralized. However, the benefit of it is that it's very quick and efficient at processing. And blockchains, however, are decentralized, as you all know, and they're transparent and distributed. However, they're very resource intensive whenever they're processing data, which makes it very difficult for us to leverage some of those calculations on the blockchain. So, what we can do is we can rely on artificial intelligence to do that processing for us. So, that's what we're going to be looking at today, how we can leverage artificial intelligence and bring that onto the blockchain. So, let's hop into it. But before we do, I'm going to introduce myself, Valentina Alexander. I'm a developer advocate at Chainlink Labs. I'm also a full stack developer. I have experience in smart contract development in Solidity, machine learning in Python, web development in TypeScript, and building backends in vanilla JavaScript. I also go by Bunch Enchantress, so it's only appropriate that today I'm going to be helping you out with doing some block magic. So let's look at our agenda. So, unsurprisingly, our topic involves two main concepts. We have functions and we have artificial intelligence, which is why we're going to complete this workshop by using functions to predict the future. But this is where the magic happens. But before we get to where the magic happens, we're going to unravel the mysteries of Chainlink's blockchain magic, and we're going to investigate the utility of functions and how they can make magical things happen. And we're also going to then review the benefits that come from summoning artificial intelligence on chain. So, blockchains lack currently the ability, or rather, not currently, but without Chainlink, lack the ability to relay messages to and from external entities, which limits the extent of their innate powers, which is why Chainlink is such a valuable solution that enables smart contracts to do what was once considered impossible. Let's look into Chainlink's blockchain magic together. A lot of words here, but basically what I'm saying here is that Chainlink is a trust minimized method for facilitating information to and from blockchains and to and from external resources. So smart contracts, they revolutionize blockchain technology by allowing for us to have very complex transactions, and we let them happen in a trustless and in a verifiable manner. But there are limitations to smart contracts, and namely their ability uh, to uh, to get information that's external to those blockchains. Smart contracts are unable to, in other words, connect to like APIs, data feeds, payment solutions, recent events, and any other off chain resources, which really limits their ability and also their adoption because we can't really do anything much else beyond like token transfers and nothing really complex and super interesting like lending, betting, gaming, on chain, et cetera, in a trust minimized manner, which is where Chainlink comes along. Chainlink allows for us to do a lot of that sort of interaction with external data and external information by leveraging the decentralized Oracle system. And we're going to look at that decentralized Oracle network and how we can leverage that with our functions. But before we do, let's look at some of the other Chainlink product lines. We have data feeds, data streams, automations, a randomizer, which is a random number generator, which is verifiably random, and also most recently cross-chain technologies for the cross-chain interoperability protocol, and what we're going to be diving into today, which is functions, which personally is one of my favorite magic powers that Chainlink passes on to smart contracts, i.e., the power to craft spells to extend beyond the realms of blockchain. And this is what is made possible by Chainlink's functions. So we're going to look into the architecture. But before we do, I don't want you to get too boggled down by the diagram and think that it's much too complex. We're going to digest it and really break it down for you. So there's two main layers that we're going to be looking at: the on-chain components and the off-chain components. As for the on-chain components, there's two major aspects of that. There's two contracts that we'll be looking at, and that is the consumer contract and the billing registry contract. The consumer contract and billing registry contract serve two distinct purposes, but we can think of the consumer contract as your main point of contact. If you look on the far left, it says EOA. EOA is an externally owned account, and that just means either you as a user or your wallet, in other words, or a smart contract. And this is ultimately going to be uh, communicating with the consumer. Off chain, we have the Oracle network, what we call the Dawn, decentralized Oracle network, also your external data providers. And in our case, we're going to be looking at API providers. So let's dive into those a little bit closer. So we have the on-chain and the off-chain components. So since contracts can't execute themselves, we have an EOA, which submits a request. And that's just a fancy way of saying that someone is requesting data. And this data request is made to a smart contract. And we can think of a smart contract as a program that exists on a blockchain that's designed to execute rules that are written into its code base. So whenever someone requests this data from the blockchain, they have to interact with a smart contract. And every contract serves a distinct purpose, and they're written to fulfill those purposes whenever certain conditions are met. So in our case, we have the consumer contract, and the consumer contract receives that data request from the EOA, and that's step one that we see here. And then step two is the consumer contract will send that request out to Chainlink Functions, which sends out an Oracle request event. It does some things off chain, which we'll get to in the next slide. And then, but before it does the thing off chain, it'll actually start the billing process, the billing registry. It'll do the thing off chain. That off chain thing will transmit data back to Chainlink Functions, which will use the fulfill and bill with the billing registry, which will then handle the fulfillment of that particular data request that was sent out. So the billing registry will just make sure that the right amount of link was paid so that it can send over that response over to the consumer contract. Now let's look at the off-chain components. For Chainlink Functions, we have the Dawn, the decentralized Oracle network, and the API providers. So the Dawn is able to either perform some complex calculation, or it can actually send out an API request to the API providers. And as you can see over here, it says that step 5, and it will receive a response back from the API providers that will be submitted back into that Dawn, which will verify that the response is formulated accurately. And then it will then transmit that response back on chain. And that brings us full circle. So let's review this one more time. The on-chain components. We have two layers: the consumer contract and the billing registry. The consumer contract is your point of contact for the EOA. It submits the external data request. It also receives the response from that external data request, and it submits the link to pay for those services. Then we have the billing registry, which administers the service payment. It is activated via the consumer calls, and it operates as an escrow service, which is just a fancy way of saying that there are certain payment contingencies that are laid out that it has to meet in order for it to fill its purpose, which is to be the biller. The off-chain components are the Oracle network and IER Dawn and the external providers. So the Oracle network, it receives that data request from the contract on-chain. It outsources those calculations and retrieves the requested data, and then it transfers that data back on-chain to the smart contract that sent out that request. Also, for the external providers, these are your off-chain data sources. They provide data for the consumer contract. That's the one that's on the far right on that diagram, and has limitless potential because any API is really at your disposal, including those that require encrypted variables, your secrets, which will show how you can do that without having to release private personal information. And also, these external providers ultimately exist external to the blockchain, which allow for you to leverage the benefits that come from external, highly efficient productions of data and consumers of data in order to offset that sort of computational layer. So now let's look at summoning artificial intelligence and how we can summon artificial intelligence on chain to tap into its powers. So there are plenty of benefits that come with summoning artificial intelligence. Namely, if you want to think about what artificial intelligence is, you can think of it as a set of data science experts that are basically able to act kind of like a human child, which is to say that it's able to absorb and learn from mistakes. It touches the hot a stove and it realizes that it's hot. Don't do it again, right? So it's really making things more and more efficient over time as it becomes better at learning new information. So it's really adaptive and it's very intelligent, which is why, no surprise, it's called artificial intelligence. And the benefits of using artificial intelligence is that allows for you to use your computations rather efficiently. They're expert data scientists, remember, so they're able to manage your data efficiently as well and effectively, and it continually improves over time. So there's a lot of ways that you can really harness the potential of AI by using it on chain. For example, you can use it to automate trading or to uh, engage in prediction markets and become better predictors than, for example, a human actor. Also, they're excellent at protocol management. So there is a lot of benefits that you can harness whenever you're using artificial intelligence. Now we're going to get into my favorite part, which is looking at where the magic happens. So we're going to apply everything that we just learned, and we're going to cast a spell with functions by summoning artificial intelligence onto a blockchains. But before we do, and while I'm pulling up the other page for that layer, I would like to allow for anyone who has any questions to go ahead and ask away to your heart's content while I'm doing this transition to the other uh, to our live coding demonstration session. And if you do have any questions, feel free to go ahead and ask them in the chat. You see, don't see any currently. What does it mean that AI is excellent at protocol management? Oh yeah, so protocol management, for example, there's a new advent in artificial intelligence. I won't go too in depth with it, but effectively, you're able to use agents, and these agents can do some sophisticated calculations that are able to play out various scenarios and find the best way to improve processes. So instead of relying on human agents, you can have um, intelligent agents that are doing so for you. Okay, let me open this. I don't see any other questions. So I'm going to go ahead and move on to our demonstration here. So you may not have this pulled up yet. I'll tell you how to get there in a second. But as promised, what we're going to do now is we're going to summon artificial intelligence by casting a spell with Chainlink's functions. Namely, we're going to acquire a price forecast that's generated by artificial intelligence. And after this demo, you'll be able to take your code and use it to cast progressively more sophisticated spells as you hone in your very own flavor of blockchain magic. So, in our demonstration, we're going to build a price forecaster and we're going to use OpenAI, but it's not going to stop there. We're going to combine AI with the reliability of smart contracts by making and receiving a forecast with a consumer contract that we deploy. However, before we begin, make sure you have the functions workshop GitHub repository, and that can be found at github.com/bunsdev functions dash workshop. So see if we can get that in the chat somewhere. Someone will put that in there. So it's buns dev bunsdev/functions dash workshop on GitHub. You'll also need your OpenAI API key, and you can get that from platform.openai.com/API keys. And I'll tell you how you can get that set up in a second. You also need access to Chainlink Functions beta, which is found at functions.chain.link. And I'll tell you how to get that set up as well. And you'll also need your testnet assets. You'll need Ethereum and a link for the Ethereum Sepolia testnet. So I'm going to get you all the link for the workshop here. I'll go ahead and post it in the chat for you all. There you go. Okay, that should give you the link to the workshop itself. However, before we continue, you'll also need access to the functions beta. So before we continue, make sure that you have access to it. And you can do that by going to functions.chain.link. You'll see a button there that says create subscription. And this will take you to a sign up page for our functions beta. And it'll ask you for your email address and the name of your subscription. It's pretty self explanatory to fill that all out. And after you fill out those two pieces of information, you'll be ready to go. And it's not going to ask for a verification on the email address. So use that information as you will and just have that ready for you. You'll also need, of course, that functions workshop repository. You'll find it in the live chat. And also, if you're looking at this after the recording, then you can just look at the description. We'll have it there. And you'll use that repository to build upon what you learned today and create your own version of our demonstration. And yes, we are using the Chainlink functions to get data on chain. That is correct. Namely data from OpenAI. So you'll also need OpenAI's API. So before we dive into the code, it's important that you have that API key set up. Otherwise, you won't be able to retrieve a forecast from OpenAI. So what you'll do is you'll sign up for an account at platform.openai.com, and then you'll navigate to the API key option and create a new API key. And if you can't find out where, you can go to the README on the GitHub. It's here, OpenAI API key, and that will take you directly there. Um, Also, make sure that you save that key before you close that window, because if you don't, you'll lose access to that key. It won't show you it again. So it's pretty important to do. So you'll also be set up with a free account ordinarily. However, if you don't, then you'll have to set up a credit card or debit card, and that will allow for you to add credits so that you can use that API. And for this demonstration, just so you know, I have done over 60 requests and it has not exceeded one penny. So $0.01. It's very, very cheap to do these processes. So after you sign up for the functions beta, after you fork the workshop repository, created your API key with OpenAI, then you're ready to cast your spells. So if you're here with us live and need any clarifications, go ahead and pop those into the chat and someone will help you with that. So if you're not watching this live, you can pause this, make sure you get that all set up. But I'm going to go ahead and continue on with the rest of what we're going to be working on. And if you're not completely ready right now and just want to follow along and watch what's going on the screen, you can do that for now and then go back and get all of those prerequisites set up, because there's quite a few things. And I don't want you to get lost and try to get all that set up. And you can just pay attention to what I'm doing. I'm going to do the same thing for you all on screen. So what we're going to do now is we're going to make some magic happen. So with casting a spell, you got to make sure that you take very careful consideration with how that spell is being performed. So let's make sure that we do every step in the right way. And remember that persistence is key. So don't give up. There's definitely, if there's a will, there's a way, and we're going to make it happen. So let's look at the workflow here in our README. First and foremost, as you can see in the README, it does say that we're going to be setting up our environment variables. This is where you will be setting up your password. So what we'll do is if you have yarn set up, you'll do yarn set password. Otherwise, if you're not sure what to use, it's here in the scripts. You'll be using npx env-enc set-pw, and that will allow for you to set up a password. That password will be used to encrypt your environment variables. So after you have your password set up, it will show um, you'll have the ability to set up your environment variables. So what you'll do is either yarn set env or npx env-enc set, and that will allow for you to set up those environment variables. The way that it'll work is it will show you what is the name of the environment variable that you are trying to set up. You'll type in either OpenAI key or the private key or your Etherscan API key. You'll set up each one of those individually. I'll ask for the name, and then I'll ask you for that private environment variable. And then what it'll do is it'll set up this .env.enc, and your .env.enc is just responsible for holding and storing those encrypted environment variables for you. So once you have those set up, what we'll do is we're going to go ahead and check out our request configuration. This request configuration is a JavaScript file, and it's responsible for your settings that you're going to be using whenever you're going to actually use the AI requests that you're submitting on chain. And the request configuration has a number of different setups for you. I'll have the code location, the secrets location, the source, your secret itself, also your arguments, and the code language and the expected return type. So let's look at each of these individually. Your code location, in our case, is going to be inline. There's only one option currently for that. Your secrets location is Dawn hosted, which just means that the decentralized Oracle network will be storing these encrypted environment variables. They won't know what the variables are themselves. It'll just know that it'll just have the ability to use those in order to connect to your external source. If you want to read about that, you can read more about how that encryption setup works by looking at our documentation. But that's outside the scope of today. Your source is the file that's going to be used to execute the on-chain request. In our case, it's called AI request.js. That's just your JavaScript file that will store that information for your AI request. And then you have your secrets, which in our case is the open AI key, because that's the secret that we're going to be using to make that request to OpenAI. Your arguments in our case, we have the token ID, the interval, the precision, the forecast method, and the historical dates. And you'll see what that means whenever we go into the JavaScript file for the AI request. But just know that your arguments start off with a zero index, and you will use these args indexed array in order for you to tap into that whenever you're creating that request later on. And you can set that up here in your configuration. And currently, the only code that we support, the code language that we support is JavaScript. So, code language is by no surprise, JavaScript. External return expected return type is the return type that you can expect from the AI request at the very end. And I'll show you where that's set up. In our case, we're just using a string, but you could also use like a uint, which is just an unsigned integer, an integer, or you just have it just keep it as bytes. So in our case, we're going to have it return a string. So now what we're going to do is we're going to look at the AI request file. And the AI request file has a few steps. We're first and foremost going to start off with the argument declaration. And that's necessary so that you're able to have some clarity in terms of like what's going on in the code, because args zero index isn't very descriptive. So we're actually going to use some constants to describe what those things are. So recall that the first constant is the token ID. And in our case, it's going to be Bitcoin because we're going to forecast the price of Bitcoin at the end of this. And the interval is D1, which just means that the data that we're retrieving, in our case, from this API, which you can find in the docs here, is from CoinCap.io, and the token ID just corresponds with how they have it set up there. The interval in our case is daily. The precision is the decimals that we want to include in our result. So if you want to have a very precise, you can go as many as 18 decimals, whatever it might be. In our case, we're using 6 decimals as for our response on that price. And the forecast method, in our case, is just going to be an IE forecast, which is a very basic forecast. And the historical days, in our case, we're going to be looking at a historical window of the 30 most recent days. So thank you all. I see the questions and answers that y'all are doing right now in chat to help each other out. I really do appreciate that. Okay. So let's look at where we start off with the price request. So we have to do a price request in order for us to feed in the historical prices into our API request that we're going to make with OpenAI. And the price request, what we'll do is we'll make use of functions.make HTTP request, which is just responsible for the HTTP requests for prices using functions. And all we need for this layer is just that URL. So since we're using the CoinCap.io API, it doesn't require any API key, which is very nice. We just use that URL and we set up the token ID and the interval. And again, you can go here for those docs and play around with it. If you want to change the token ID, make it a token ID that maybe it's Ethereum or Chainlink or whatever it might be. You could change that there. Same thing with the interval. And what we're doing here at line 26 is we're actually requesting and then waiting for that request response to be sorted. So the price request here is just getting the response over time, and it's getting that time element of that response and it's making it into descending order, which is what this function is doing. It's just uh, returning all of those different data elements in reverse. So that way we're able to get the most recent prices reported back to us. And you'll see why we do that in a second. So, number three is the response handling. We have the prices array set up with just an empty array called prices. And then we populate that array starting here at line 38, where we start to get those historical prices from the response that we requested up here with the price request. So what it'll do is it says it's a for loop. So it's starting off with 0 and it is going through and iterating through all of those historical days that remember we asked for 30 days worth of history. So it's going to do this 30 times and it's going to add to the prices array 30 different prices. And since we're doing it in descending order, since we have that price response in descending order, it'll get the price for each of those, starting off with the most recent price and going back 30 full days. So that's all that's doing right there. Then we're going to do some prompt engineering. Here, what we'll do is we have our prompt set up, and what we want at the end of the day is just a string that is only telling us the number. So this is how I did it. I used historical data colon prices, and that price is going to look something like 1, 2, 3, 4, 5, 6. Like these are all just a bunch of prices that are going to be there. Hopefully, Bitcoin wasn't 1, 2, 3, 4, 5, 6 recently, but whatever the prices were for the last 30 days for Bitcoin, it's going to be spit into here with prices in an array. And then I ask it based off the historical data, use a, and then forecast method. In our case, it's the naive forecast to predict the price at the next timestamp in the time series. No explanation, which is part of that prompt engineer. We don't want any explanation, which Chat is great at doing, is giving us some explanations, but we don't need that today. And only report a float number with no dollar sign and no context. A float number just means a number with a decimal, and that's all I really need for that. That will get us exactly what we need, but what we need before we get to that response is we have to set up our open AI request. So our open AI request is set up again with the functions make HTTP request, which is just an HTTP request, looking at the open AI's API endpoint, which is here. The URL for the most recent one is here. However, they do change it over time. So make sure that if you're watching this in the future as a recording, make sure that you go to OpenAI's documentation for their API and see what their most up to date way of setting up this request is. Because they do change this rather quickly. It's different from what it was a year ago, for example, but you'll need the right URL. Also, the method in our case is post. Our headers are the content type, which is application JSON, and the authorization, which is your API key. So whenever you're getting those secrets, you can do secrets.api key because that's the secrets pathway that we have for our API key that we set up in our request configuration. That's here, secrets.api key. That's how that logic works. Then we have our data, and this is defining the data payload that we're going to be requesting. So the way that OpenAI likes for its request to be made is we specify the model. In our case, we're using the most recent version that's available to us, which is GTP, GPT-3.0-turbo. If you're looking at this in the future and we're not being run by AI, then hopefully GPT 4.0 is working really well and doing some cool things, or whatever else it might be by then. I'm very excited to see the future of AI. It's changing almost daily at this stage. And then you're going to set up your messages, and the two roles that we're going to have here are the system role, which is just telling the system who they are and what they are doing effectively. And I just have a very basic content line for what the system is and doing. I'm telling the system that you are forecasting the price of a token. So if you really wanted to play around with that, you can. You can make them be anything you want it to be effectively, and it'll play that out. And the other role is a user, that's you. And what you're doing is feeding in the content. That's that prompt that we set up over here. So the way that this will work is if you have like a chat GPT sort of set up uh, for your like in your personal life, you can test around and play around with these prompts and have it set up so that it's able to tell you the response of the prompt before you put it into here, and you can play around with it that way. Or you can change up the script here and change up that prompt, and I'll show you how to simulate this request before you submit it online or on chain. And that way you know what you're going to be looking at whenever you do submit it on chain. You can also specify the timeout, which is just how long you're willing to wait for this request to be sent out. Your max token, which is really useful because that way I'll increase the font. Is that big enough? Hopefully that's hopefully that's big enough. I increased the font a little bit for you all. Thank you for that feedback. So what you're able to do here is you have the prompt, the max token, and the response type. Max token is really useful because that will limit how much you're paying for that request. And we have the response here, which is just awaiting, which is just letting that request get submitted. And the result, you'll use this sort of formatting. It's getting the response, dot the data here, and then it'll get the choices that are printed out from there. It'll get the first index choice, it'll get the message dot content. So that is just the way that we formulate that string response so we can get the result. Here I do a little bit more manipulation with that result. I get the string result. I specify the precision of that result, which means that you first have to make it into a number, and then we pull it back into a string. And then we console log it so that we can see whenever we simulate it what that response looks like. So let's go ahead and go ahead and simulate that request, and which is really important that we do that simulation prior to actually bringing that on chain. So in our case, I have a setup for it in the package JSON. There's these scripts here, recall, and I have simulate. So we're going to do that yarn simulate. Okay. Um, so what it's saying here is that there's an issue with the way that the secrets.api is set up. So what that just means is that I don't have the API key set up there as they desire it to be. I'm not going to do that on screen, but just know that the way that that's supposed to work is it'll simulate that response out for you. So hopefully that works for you on your end. So you're going to want to do is a .env, um, .enc, sorry, a .env, and then you're going to do what's here in the open AI key. And you're going to set that up there so that you're able to have your AI key there, open AI key there. I erased mine for this tutorial. So it's not like leaked out there, but it'll allow for you to go ahead and simulate that here. But we won't need to worry about that right now. We can move on to the next step, which is looking at our smart contract. I already know that it works on my end, so make sure it works on your end. Here, we're going to look at the part that is denoted with these Ds here. That's for the demonstration purposes, because I got this functions consumer from the template for functions. There's a functions template or starter kit rather that's accessible at smart contracts. You can find that on GitHub. However, I have it here in the demonstration as well. In our case, since we're looking at a forecast, we're going to update that response name into latest forecast, which remember is just a string. And then we're going to be emitting two events, the OCR response and the price that's forecasted. So that's what these changes are up here. And with the OCR response, we have that request ID that we had submitted in order to make that request. And we'll get into what the request ID is and how we set that up, as well as the result that was submitted and if there is an error, then any error that was reported. So all the magic happens here in our send request. I don't make any changes to the send request from the template itself. The send request part does, however, have an internal functionality, and that is the fulfill request. So you can see internal override. So whenever it's actually fulfilling that request, what it does is it is able to store the latest results, or if there's an error, the latest error. And then it'll also give you that request ID and the response that was submitted after you make that request. So what I have here again within the documentation is the latest request ID is updated to that request ID that is given out from that fulfill request implementation. Also, the OCR event, we're just filling that out with the request ID, the response, and the error. and then the latest forecast, which we do a little bit of manipulation here, and that way we can make it human readable. And I'm just getting that response, which comes out here. As you can see, it's bytes, which just means that it's not human readable. So we want to make it human readable by using abi.encode packed and then casting that as a string, and then emitting that event for the price forecast as a string. Okay, looks like everybody is doing well in the comments. So if you are here live, feel free to ask any questions if you have any. I don't see any questions. So hopefully all are fully understanding what's going on here, or at least mostly understanding. If not, you may have to rewind, play back slowly, or do whatever you might need to do. But we're going to move along and do yarn deploy. So just to recap, we've set our environment variables. We set up our passwords, set up our environment variables. We also did our simulation. And now what we're going to do is we're going to deploy that contract. So what you'll do is either yarn deploy, or if you don't have yarn, you'll do npx hard hat func func dash deploy dash consumer, and then you'll specify your network. In our case, we're going to be using the Ethereum Sequoia network. And if you want to verify it, then you could do verified true. Okay, so whenever you do the deploy, it's going to look like this. So what it will look like is it will say, it'll say that you have deployed the contract to a particular address, and then that address will be updated here in your subscribe and in your request and in your read functionalities or scripts. So I'm going to show you what that looks like. You just update it like this, and then you're going to save it. Make sure that, again, it's aligned with your contract address. So after you've deployed it, it's going to take some time. It's going to look like this. Once again, it's going to print out that information, and it'll give you that link to the successful um, deployment of that contract. And then what we want to do next is we want to do subscribe. So what you do with your subscription is we use this so that we're able to have a subscription that is able to take in that desired link amount that we're using to pay for those subscriptions. So you're going to have to specify your target network. In our case, we're using Ethereum Sequoia, and then the amount of link that we're going to be adding to it. You can make that whatever you think is necessary. I just have 5 there just as a default. And then you're going to specify your contract address. So let's go ahead and do that now. Hopefully this one works. Yarn subscribe. Okay. So whenever you do subscribe, it's going to give you a subscription ID. And I'm going to stop trying here in the thing. It will work for you on your machine. If not, ask me questions later. And you're going to look at the subscription ID. You'll update that subscription ID here, and your subscription ID will be set up so that you're able to read that. I'm going to try something real quick, actually. Um, do subscribe. Okay, whatever. So what it'll let you do is it will also let you make that request, and you'll specify again that subscription ID, and then that will allow for you to submit that request so that it's able to update on chain your smart contract. And it does this fulfill request action here, which will update your latest request ID as well as your latest forecast, which is the really neat part. And then you'll be able to run yarn read or npx hard hat func read, and again, specify that network and your contract, and it will allow for you to read out that response for you. And if you're curious on how these actions are set up, where it says like func read, func request, and func sub create, what you'll do is go here in your tasks, and you'll see that there's the ability to do the read functionality, your request functionality. It's all laid out here. And if you know how to read JavaScript, then you can play around with this if you'd like and see what the output would look like whenever you do those sorts of requests. And it does a lot of neat things like tell you if you have insufficient funds or if the request fails or if the request succeeds, and it'll print that all out into your console here. So, for example, subscribe. Um, it'll do this for you. It'll look it up for you, and it will do all the necessary steps for you to make sure that you're able to look at your subscription. Just an example. See if there's any questions. Share the resource links in the discussion windows panel. Okay, so if you scroll up, you'll be able to see the GitHub repository. The GitHub repository has this README here that will walk you through all the setups that you'll need for simulating the functions, creating your subscription request, and making your request, and submitting and making your query, which is just looking at that functions consumer contract that you deployed. Alternatively, if you're not too comfortable using the terminal, you can also use the functions UI here, which will take you to the UI so that you're able to see that response that's generated from the price forecast that you just created. And yes, there's also even a functions playground as well. So if you want to play around with functions playground, you can do so as well. Thank you so much, Tippy. So I'm going to go ahead and wrap it up here and then leave it up for any questions. But if you made it this far, congratulations. You've successfully been able to read a response and you're now an official summoner. So with great power comes great responsibility. So make sure you subscribe to this video. And you also check me out at zeroxbuns.com where you can see some articles that I've written on smart contract development. You can find all of my socials like my Twitter or X or whatever they may call it in the future, as well as my LinkedIn, etc. And if you have any questions, go ahead and tag me on Twitter or X, and I'll answer any questions that you may have there. If you have any other questions and you want to put those into the chat, we can allow some time for that as well. Otherwise, thank you so much. And this was my very first workshop as a developer advocate here at Chainlink Labs. So I appreciate you all being here and being a little patient with the inability to show you those results live here in the terminal. But
Congratulations. Wow.
thank you so much.
You broke a leg. Awesome. Well done. Amazing session. Thank you so much. And guys, last call for questions while we have Wal here. If no more questions, then make sure to join us tomorrow at 1 o'clock Eastern time for a session called Running Nodes on an Eco-Friendly Infrastructure with Simon Thomas from Exeon. Well done today. And we shall see you tomorrow. And happy building, y'all.
Thank
Bye.
you.
Bye.